Hello everyone, I hope you are doing well. So here's the question that we are going to solve today, and let's see the first part. So here's the part A, which says that given a direction v equals square bracket starts and it's h prime, k prime, l prime. Now these are the Miller indices of the direction, okay? And as you can see, you can count here that they are the three digits here. It means they are the three Miller indices here, and it corresponds to a three-digit index system, okay, that we call as Miller indices simply. So what it says that how to determine the corresponding four-digit index. So let me tell you first that there are the two index system that we use to describe the directions in the planes. One is the three-digit index system that we simply call as Miller indices, okay? If you call Miller indices, that it means it is the three-digit index system. So there is another system which is a four-digit index system, and we call it as Miller-Brevis indices. Okay, Miller-Brevis indices are the four index system where they are the four indices in order to describe the directions in the planes. Okay, and these indices are described as h, k, I, and l. If the Miller indices are described as h prime, k prime, l prime, then the corresponding Miller-Brevis indices, which is actually the four-digit index, will be denoted by the unprimed alphabets, which will be H, K, and I, L. Okay. In some books, they are denoted by U prime, V prime, and W prime for the three index system. Okay, and for the corresponding Miller-Brevis indices or the four-digit index, they represented by U, V, T, W. Okay, so it's completely up to you that what kind of notation you are using. Okay, primed for the Miller indices and unprimed for the Miller-Brevis indices. So in this question, what we are aiming to do is to determine the equations specifically that we can use to convert the three-digit index into a given three-digit index into a four-digit index. Okay, how we can determine h, k, I, and l if we are given with the h prime, k prime, and l prime of a direction. Okay, so our given direction, so if a direction is given, then you can describe that direction by using three index system and also by using the four index system. Okay, so both of the notations are equivalent and we can use them interchangeably whenever it's better, because the four index system gives you some extra information about the direction, okay, that hidden information that is like highlighted. Okay, um, it gives you one extra index, one extra information about the direction. Sometimes we don't need that information and sometimes we need that. For hexagonal crystal system, for example, we need that extra information in order to completely describe the direction. That is why we use four index system in order to draw the directions in hexagonal crystal system, but it is not needed in the other crystal systems like cubic crystal system. Okay, that is why for the cubic crystal system we usually use the three index system, because we don't need the third index. It's not needed, but for HCB it's needed. That is why we use the four index system. So let's begin with the solution, and here the direction is given, and which is V. Okay, and it is given in the three-digit index system, and the indices are named as h prime, k prime, and l prime. All right, and we want to convert that, and let's use v prime also here, and we want to determine the direction in terms of the four index system, four-digit index system. Okay, and there is an extra index here which is I. Okay, h, k, I, and l. All right, so this is something that we want to determine. We want to determine h, k, I, and l if we are given h prime, k prime, and l prime. Okay, so there will be basically some equations that we are going to derive that will relate h, k, I, and l with these indices. Okay, and we can simply plug these values into those equations and we'll get h, k, I, and l's value. Okay, so as the directions into in both, not two, okay, in both index system are equivalent. So we can write, as I told earlier, that the similar direction can be expressed, can be represented by the 3 index system and also by the 4 index system, and both of these index system are equivalent, like they are they are representing the same thing but in different words, okay, in different numbers. So in 4 index system, they are the 4 coordinates also, okay, they are the 4 vectors, you can say, which is the a1 vector, a2 vector, a3 vector, and the last one is the c vector, or you can write z vector also. It is similar to say that if we call the 3D system, which is x, y, and z, and if we write the 3 axes vectors as x vector, y vector, and z vector. Similarly, here we are using the a1, a2, a3, and c notations. Okay, it's up to you what kind of notation you want to write. Okay, but more for HCP, because the 4 index system is usually used for HCP, and in HCP the 4D coordinate system is used. And 4 index system means the 4-dimensional coordinate system also. Okay, so that is why we'll have 4 vectors corresponding to each of the index, and for h it will be a1, for k it will be a2, for I it will be a3, and for L it will be c. Okay, and since I is not here, that is why the a3 vector or the coordinate will not be here too. A3 coordinate is an extra coordinate in the 4-digit coordinate index system or the coordinate system. Okay, so here there will be 3 vectors only, and that will be a1 vector, a2 vector, and the c vector. They will not be primed because the axis lines will be similar in both of the systems, but a3 will not be there and a3 will be here as an extra coordinate. That actually changes the indices number and makes it different from the 3 index system. So now we know the axis lines and all the that stuff. Now we can write that to describe a direction, okay, in terms of a vector, what we do is to multiply its Miller index, okay, with the vector. Okay, so h prime is the index in the a1 direction, so a1 vector, h prime into a1 vector plus k prime into a2 vector, okay, and L prime into c vector equals, okay, this is something that we are writing in the 3-digit index system, and that will be equivalent to h into a1 vector plus k into a2 vector. This is something that we can write in only if the vectors are considered. Okay, here the vector notation is necessary. I into a3 vector plus L into c vector. All right, let us call it as equation number 1. And for 4-digit index system, the Miller-Brevis indices, you can also write it as the Miller-Brevis indices. Okay, we know that h plus k plus I, that sum is equals to 0. Okay, that sum is equals to 0. The sum of these 3 indices is equals to 0 in the Miller-Brevis indices, and this is how we define that system. And similarly, vector sum of the a1, a2 and a3 are 0. Proof of this thing is irrelevant in this problem. I can easily prove it, but it's not relevant. Okay, its description is not relevant right now, so you should just use it as it is. When in next video I'll be drawing the hexagonal crystal system, then I'll explain that fact, because these three vectors forms the basal plane of the HCP structure, in which you'll clearly see that these three vectors forms a closed triangle. Using the head to tail rule on that on these vectors will give you this equation. Okay, so these are the basically three equations that will easily that we can use to get the required formulas. Okay, and it is very easy. Next round, you should just remember these three formulas. First is sum of the first three indices is 0. Okay, and sum of the first three vectors is also 0. All right, for the Miller-Brevis indices, and both of these systems are equivalent as they represent the similar direction. Okay, so these are the three things that you should remember. Now let us take a3 here and take these two vectors in this side of the equation, and we will get minus a1 minus a2. Okay, and we'll put this into this equation number 1, and the reason is there is an extra a3 here. Okay, and all of the other vectors are like similar, but a3 is a very different one because it is not here, so we want to eliminate a3 vector. So for that purpose I just found the value of a3 here, and we'll put that value right here, and let us do this. So in place of a3 I'm writing minus a1 vector minus a2 vector plus lc vector. Okay, now let us multiply I with these two and simplify that equation. Minus I a1 vector minus I a2 vector plus lc prime. Now we'll take common a1 from these two expressions and a2 as common quantity from these two expressions. Okay, and after that what we get is a1 right here. Okay, and plus h will be left behind from this value, and minus I will be left behind from this value. Okay, similarly we'll take common a2 from these two expressions, and k and minus I will be left behind. Okay, plus lc vector as it is. So let me rewrite it here. H prime a1 vector plus k prime a2 vector plus l prime c vector, that is equals to a1 vector h minus I plus a2 vector k minus I plus lc vector. Vectors are usually written on the right side, that is why let me write it on the right side. Okay, I just as a convention. Okay, so this is something that we got till now. Okay, next step is to equate the vectors. Okay, it is the property of vectors and variables that if they appear on both sides, then we can simply equate them. Since both of these equations are equal to each other, and a1 a2 and c are the independent vectors, they do not depend on each other. That is why we can simply equate this expression with this. So now we will equate the vectors, the three vectors on both sides of the equation, and what we get is equating a1 vector will equate one by one. So a1 vector, so the coefficient of a1 vector right here in this side of equation is h prime, and that should be equals to the coefficient of a1 vector on the other side of the equation, which is h minus I. Okay, so this is one of the equation. Let us call it as equation number 4. Okay, that we get, and now we will equate the variable, the vector a2. Okay, and we get k prime equals k minus I. Okay, this is equation number 5, and equating vector c, a vector, don't need to write the vector word, so equating it gives L prime equals L, because okay, this is, let's say, equation number 6. These three equations are actually the transformation equations if we are given the h, k, I and L values, and if you want to find the three index the three indices from the four indices system. Okay, if we are given with h, k, I and L, and if you want to convert the Miller-Brevitz indices into Miller indices, then these three equations, these three transformation equations are used. Just for information, I just told you right at that point, but these are not the equations that we are to find in this equation. Okay, we want to find the equations which are expressed in terms of h prime, k prime and L prime only. For example, we want to find out the value of h, okay, in terms of h prime, k prime and L prime only, that contains these three variables, not any other variable. Okay, similarly for k, similarly for I, and L is equals L prime is the final equation. Okay, we don't need to do anything else on it, because it's simply L equals L prime. It means that the this index doesn't changes in both of the systems. Okay, so we need to find out the value of h, k and I in terms of h prime, k prime and L prime, and for that purpose we'll use these two equations and this equation. Okay, this alone will suffice to find out the value that we are seeking. So let us put the value of h prime and k prime all together into this equation, putting 4 and 5 into, this was equation number 2. Okay, as I named it earlier. So we'll put the value of h and k from these two equations into this equation. So the value of h and k could be found like that. Taking I from this side to this side, it will become h prime plus I equals h, and for that one it will become k prime plus I equals k. Okay, so these are the values of h and k, and we'll put these two values into this equation, and what we get is h prime plus I plus k prime plus I equals 0. So it becomes h prime plus k prime plus 3I equals 0. And the value of I will become minus h prime minus k prime. We will take these two on to the side of the equation, and I will be 1 by 3. It is multiplied right here, and it will be divided on to the other side of the equation. So taking minus as a common quantity, so this is the final transformation equation for I. As you can see here that I is expressed in terms of primed variables only. There is not any other unprimed variable here. So this is the final transformation equation for I, and it is L equals L prime for this one. So we just need to find out the value of now h and k, and for this what we have to do is to let us call this equation as equation number 6 maybe. So we know that from equation number 4, to get the value of h, we'll put the value of I as obtained from equation number 4, and to get the value of k, we'll put the value of I from this equation into this equation number 6. Okay, one by one we'll do that, and we had from equation 4, h prime equals h minus I. So the value of I will be, we'll take I into this side of equation and h prime into this side, so it will become h minus h prime. Okay, so we'll put this into equation number 6 and we get h prime plus k prime plus 3 into I. So h prime plus k prime plus 3h minus 3h prime equal to 0. H prime minus 3h prime becomes minus 2h prime plus k prime as it is plus 3h as it is. We want the value of h here, so we'll keep h here and we'll take these two values into this side of equation, and it will become 2h prime minus k prime, and dividing 3 onto this side equation, it becomes this. So this is the final transformation equation for h as it is expressed in terms of primed variable only. Okay, so now we will put from equation 5, which will give us k prime equals k minus I. Yes, and I is k minus k prime, putting into 6 again into this equation. Okay, we get h prime plus k prime plus 3 into I, which is k minus k prime equal to 0, h prime plus k prime plus 3k minus 3k prime equal to 0. So this is h prime plus k prime minus 3k prime will give us minus 2k prime plus 3k equal to 0. We want the value of k, that is why we'll keep 3k in this side of equation and we'll take these two values onto this side of equation. And so this is the final transformation equation for k. So if we write them all together, so this is what we get. Okay, k is 1 by 3 into 2k prime minus h prime. Okay, and I equals minus 1 by 3 h prime plus k prime, and L equals L prime. These are the final transformation equation. So this is the way we can determine the 4-digit index from the 3-digit index. If we are given with h prime, k prime and L prime, we'll simply put these three values into these 4 formulas and we'll get the 4-digit index. Okay, for the direction, since it's direction, so enclosed in a square bracket. All right.